Okay, so this is our math team review of Conics sections. This one's to help you out, Archel. Number 4 is where we left off. We're picking back up. We're looking at hyperbolas. Now, hyperbolas, just want to go over here and just have some review. You might remember that, we could have a center and we could have a vertical distance and a horizontal distance from the center. And then these corners of the box make asymptotes, I should say, to the point where what's going to happen is you can see that you might have a hyperbola opening to the right and to the left. And, this is your center. I'll call it H comma K. If that were the case, you're opening in the X direction. So this would be X minus H quantity squared. This is an A distance. That's all over A squared minus Y minus K quantity squared all over B squared. Your B is that vertical distance that you go from the center up and down to create your box, and that's always going to equal 1. But likewise, your hyperbola does not have to open to the right and to the left. What you can see very quickly is that you could form a box. Once again, you can have asymptotes. The asymptotes control the branches here. And you could see more or less that, we could be opening up and down. And, you could once again have an H comma K. But this time, we'd call the vertical distance that we're going from the center A. And we'd call the left-right distance B. And this would be Y minus K quantity squared all over A squared minus, and over here we'd have X minus H quantity squared all over B squared equals 1. Whatever is positive indicates the direction that we're opening up. So if the X terms are not being subtracted, if they come first, we open right and left. Likewise, if our Y terms come first, if they are positive, then we open up and down. Also, there are foci, and that can come into play too. You can see that you could have a focal length C. You could have a focal length C right here. In either case, what you're going to see is that focal length C comes from the Pythagorean theorem. We'd have C squared is always equal to A squared plus B squared. So that's just a very, very quick review of hyperbolas. But let's take a look real quickly at this problem right here. It says a hyperbola has two asymptotes, and you can think, well, my goodness, they don't give us very much information other than those two equations. And they're saying, oh, yes, it also contains a point 0, comma 12.
C then be root 6?
Well, let's see. Where those asymptotes cross, so important, is going to be the center. And I do want to point that out to you guys. Super, super, super important. That's really why they're giving us the equations of those asymptotes, regardless of whether you're opening up or down, left or right. Your asymptotes will cross and meet in the center. You'd say, well, wow, isn't that cool? Well, let's see how that's going to go. How could I find where these lines cross? Well, let's do substitution. We could very quickly set 3x plus 1 equal negative 3x plus 7. Set those y values equal. It's like substituting the two y values equal to each other. And of course, I can add a 3x over here, simultaneously minus a 1, and I'll have 6x is equal to 6. That means x is equal to 1. And guys, regardless of which equation I'd plug in, that x equals 1 into. Imagine it's the first one. 3 times 1 is 3. 3 plus 1 is 4. You get y is equal to 4. That's going to be your center. Okay? So we've got 1, 4, and we can begin to just, try to make some sense of that. Here's 1, 4. And, we've got 3x plus 1 would, look like this. We've got a slope of 3. And here's 4, 5, 6, 7. That's, right over here. And you can see 0, 12. 0, 12 is up here. So that means that it's within this upper bound, this top section of the lines. So hopefully if you can see that, if it's 0, 12, we now know that this hyperbola opens up and down. Now, if it opens up and down, my goodness, that is incredible. We can say, well, from what we just saw, it's y minus k quantity squared all over a squared minus x minus h quantity squared over b squared equals 1. And, right now we can even say, well, if our center is at 1, 4, we've got h, k. So this thing becomes, if we write this out, y minus 4 quantity squared all over a squared. Then I can say minus x minus 1 quantity squared all over b squared equals a 1. And of course, we also know that we've got the point 0, 12. If I were to plug in x equals 0 and y equals 12, that equation would be true, right? But what we have to be very careful about, and I just want to show you, let's go back to this scenario real quickly. What I want to show you is, look at this green, let's just look at this positive slope right here. You can see that that slope would be rise over run. And this green line here, for this green line, you could say, well, look, going from your center, you go up 3, you go right B. So you go up A, you go right B. So the slope is going to be A over B, right? Likewise, you could say, no, wait a minute, there's also another slope that's negative, isn't there? You'd say, absolutely, most definitely. But I guess what I want to show you is that if you had y equaled 3x plus 7, and if you had y equals 3x plus 1, I guess what you can see very quickly is that slope is 3. So 3, is it negative? Well, there are 2 lines. There are 2 lines. I'm just focusing in on the positive slope in green right now, right? So that's going to be y equals, and one of them was negative. It was negative 3x plus 7. So sorry, I see what you're saying. I'm just focusing in on the positive 3x plus 1 right now. Why? Because you're going to say, look, you're going to go up so much, you're going to go over. You can say, well, wow, this is really cool. I might be able to figure this out. So, in other words, A would equal 3B. So I can say A is going to equal 3B. And ultimately what we're trying to do is we're trying to find the distance from the center to one of its vertices. So we're going to have to get to the vertice. But my goodness, if I were to plug in x equals 0 and y equals 12, if I was to also substitute in that a was equal to 3b, I'd be able to find my a and b then. So let's do that. I'm going to plug in a 12 right here. I'll get 12 minus 4 quantity squared. I'm going to plug in my x is 0. That's 0 minus 1 quantity squared. If a is equal to 3b, a squared would be 9b squared, wouldn't it? And it would only take us a moment. 12 minus 4 is 8, and 8 squared would be 64. And, negative 1 squared is just a 1. We'd have that thing right there. And, at this point, wow, we should be able to solve and make this happen, right? You could factor out a 1 over b squared if you'd like, and that would be, fine. You could do that. Let's do that. If we factored out a 1 over b squared, this would be 64 over 9 minus just a 1, right? And that's really 9 over 9. So 64 minus 9 would be 55. So here's 1 over b squared times 55 over 9 equals 1. And tell you what, I'm just going to multiply both sides by b squared, and I'll have b squared's equal to 55 all over 9, right? So at that point, I can take a square root, and I can say b is radical 55 all over a 3, right? Now, at this point, please also remember that a was equal to 3b. So if I know what b is, a is going to be 3 times radical 55 all over 3. So your a is going to be radical 55. So here are your important pieces of information. Now, realize what we did. We found what our center was, right? Our center was 1, 4. Our center was 1, 4. And remember that we're going to go up a steps. So here's 1, 4. And we're going to go up radical 55. So we're going to go up from that. So this point right up here is still at 1, but then it's going to be 4 plus radical 55. So what we've really got is that's your actual vertex, but they just want to know the distance from the center up to that. That's A. A is just radical 55. That's your distance that you move up. For a second, I thought they wanted the actual vertex, which would be what I wrote. But that distance is just going to be your A distance. A is always the distance from the center to a vertex. And that is problem number 4.